So if we've got the secant line, let's plot some points. If this is A, what would this point be? A comma, whoops, f of A. Thanks, Liv. Isn't f of A just fancy for y at that x value? That's good. And then what about this point over here? This would be, thanks, Liv, bf of B. And you guys, I want to find the average. Mean just means average. What's my average slope? How would I do that from these 2 points? Change in y over change in x would look like what from these 2 points? F of B minus f of A all over. You know it. That's my average slope. That is my average slope. Average rate of change, if you will. And the mean value theorem says as long as my function is continuous and differentiable, no cusps, no corners, no discontinuities, there's going to be some other point. There's going to be some other point, and I'm going to go ahead and draw a tangent line as parallel to that secant line as I can. I'm going to draw some tangent line that looks parallel to that secant line. And I'm going to name that x-coordinate C. There's going to be some tangent line that has the same slope as that average value. And how I'd say that over here is just, that's going to equal f prime at some c value. That's going to equal my derivative at some new x-coordinate c. Check it out. Could it happen more than once? I know your graph on here did not come out well. So maybe we just go ahead and go over what did not print out well. We've got a cute little woo, 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 woo. And we've got that on this closed interval from A to B. And then maybe you draw yourself that average slope. Just connect A to B, and that right there is my average slope. If this was maybe my graph of my velocities coming to school, I was speeding up, you know, I had those positive velocities on average. Okay. Does it look like there's not only one time that the tangent line looks like it's parallel, but doesn't it look like there's 2 times here? So on here, there would be 2 places where the derivative equals that average slope. Yeah, it could happen as many times as we want. The mean value theorem just guarantees it's going to happen at least 1 time. So let's put this into like an actual definition. If my function is blank over a closed interval and blank over the open interval. So the 2 different words here is we're talking if it's continuous from one endpoint to the other endpoint. Those endpoints have to be closed, meaning they have to be colored in, right? They're closed from A to B. They got to be included. And then it's got to be differentiable from A to B, not including the endpoints, because I can't have a slope at a point, like at an endpoint. Then there's at least 1 point C within that interval from A to B. We said C was within A to B, and this is where we're just going to put that definition, where my average value, average rate of change, my bad, equals to the derivative at some C value. So if we think, this is what they gave us. Oh no, they're attached. Okay, this is what they gave us. Let's go see. It says, all right, find C such that the derivative equals the average value. You guys, we got to go find f of 5 minus f of 2. Notice that I just used those endpoints. That came from right here. So we got to go find f of 5 minus f of 2 all over 5 minus 2. That's going to find me my average rate of change, which again, if I do that on my picture, is just going to be from this to this. All right, we're going to go find that slope of that secant line. You guys, f of 5, how would I find that if this is my function? Plug it in. What's 5 squared? 25 minus plus, good, minus, don't forget a parenthesis, because we got to subtract, now plugging in 2 to that. What's 2 to that? 2 squared is 4 minus 12 plus all over 5 minus 2, 3. And we're in class, we're in a safe space. So how about 25 minus 30 is negative 5 plus 8, 3 minus 4 minus 8. Oh, see, Tom, it's not just you. 4 minus 12, negative 8 plus 8. Beautiful. What is my average slope? 1. Wow. That doesn't really look like it on my graph, but I guess, oh, it does look like it. Up 1 over 1. What a goober I am. Looks like it. Okay, so you guys, look at what we just did. We just found this side. Whoop. And they're saying, we just got this side to be 1. They're saying that's going to equal the derivative somewhere. And what our job is to go find out what is that somewhere. We got to go find what is f prime of x. Can we go find our derivative? I'm going to go get rid of this. I'm going to go get rid of this to build us some space. What is f prime of x? Oh, golly, I know it's been a while since we've done calculus. 2x minus 6. And look at what this is saying. That my average slope, which is 1, has to equal the derivative at some point. So all I've got to do is say, when does my average slope equal that? When does my average slope equal that? When does 1 equal 2x minus 6? People, let's do it. Add 6 to both sides. Thomas is going to practice that. Love you. Love you. I can only say it because you're my nephew. We get 3.5. See if we can keep it together. There we go. Okay. It says, all right, now we've got a square root function. Now we got a square root function. From 1 to 3, it says C is the number that satisfies the mean value theorem. The mean value theorem is saying that the average slope of this function will equal the derivative at some point. Can we go find the average slope? F of what minus f of what, do you think, based on this question? What are my A and my B? What are my endpoints? Yeah, 1 and 3. I'm going to do f of 3 minus f of 1 all over 3 minus 1. That's my average. F of 3, what would 4 times 3 get me? 12 minus 3. 9 square root of 9. 3. Minus f of 1. We got to throw a 1 in there. What's 4 times 1? 4 minus 3. Square root of 1. Beautiful. All over 2. Thomas, 3 minus 1. And why were these both 1? That's my bad. These just both happen to be 1. I wish I didn't do that, but it is what it is. That's my average rate of change right there. That is this. We got to go see where that equals the derivative. Can we go find the derivative of this? We sure can, people. We are smart. Let's go find f prime of x if this is f. Whoo! What's my outer? Yeah, isn't this something to the 1/2 right here? This is 4x minus 3 to the half. So we got to do a little chain rule. The derivative of this outer, Sadie just said, bring that 1/2 out front. Leave the inner. So I got 4x minus 3. What does my exponent become?
Negative 1/2.
Nice, buddy. Take 1 away from my exponent. Don't forget about multiplying by the chain rule. I'm multiplying that by 4. Beautiful. You guys, we got to go see, when does my average rate of change equal my instantaneous rate of change? At what x value? So we're going to set those equal to each other, but is it just me or is this hideoterous, as they'd say in Wicked? Okay, so this is heinous. Can we make it prettier? For sure. What's half of 4? 2. So I'm going to say, all right, that's going to get me a 2 here. And then what about this negative exponent? Where should we move it? Let's move it down. So I'm going to say, when does 1 equal 2 over, I could rewrite this as 4x minus 3 to the 1/2 on the bottom, but could I also write that as root 4x minus 3 on the bottom? Right? Something to the half is a square root. Moving it down would make it a positive 1/2. Are we okay with that, you guys? What are you saying, Maine? Yeah, we can just multiply by that root 4x minus 3. 1 times anything? Uh-oh, it's the least favorite word from Mario Iono. He does not like when I say anything. What are we doing first to simplify the square root? Square both sides. We get 4x minus 3 is 4. 4x equals 7. X is? Very good. So this next page says, the table gives selected values of a function. Can we use that mean value theorem to say that there is some point C, some x value, such that the derivative is 5 from 4 to 6? From 4 to 6. That mean value theorem says, one more time, if my function is continuous and differentiable, then there has to be some x value where the derivative equals my average slope. You guys, by them saying this, since they said f is differentiable, if it's differentiable, there are no cusps or no corners, and there's always a slope. Does that imply that it's continuous? Yeah. So because they say it's differentiable, then we also know it's continuous. And those are both musts for the mean value theorem to apply. So that's huge. If it's differentiable, then it's continuous and we're good. Can we use it? Okay. Is my slope going to be 5? Is my slope going to be 5? Can we go find my average slope from 4 to 6? What minus what over what minus what? 7 minus 3 over 6 minus 4. Is that what you said, buddy? Beautiful. Thomas? 4 over 2. Is that what we're getting, people? Does that equal 5? No. So we're going to say no. It's going to equal 2. And AP is not going to ask us something like this, so I'm not going to harp on this. It's just going to need to equal the average rate of change. And if that's not my average rate of change, no, there's nothing more I need to do here. Okay, you guys, do you think that we can use the mean value theorem to say that I guarantee there is a some x value that has a slope of -1 on this interval from 0 to 2? Does the mean value theorem guarantee that there's going to be some x value that has a slope of -1? What would be my average slope here? What minus what over what minus what? What's that? Oh, snap. This one is. So the mean value theorem says, oh, geez, we only know 4 points on this graph. That's all I know. But because this graph is nice and curvy, and that means it's continuous and differentiable, that the average slope, there will be some x value within that range from 0 to 2 that has that exact same slope. So we're going to say yes. We're not going to worry about our wording on that one too much yet. What could happen if the function is continuous but not differentiable? If it's not differentiable, do you agree this graph has a what right here? Corner or a cusp, however we want to call it. Here a function, this function, do you agree that this function is continuous? Did I have to lift my pen at all? Thomas is continuous, right? It is continuous. Sorry, I'm writing in a fat pen, so I got a continuous. But it fails to be differentiable. Thank you. I'm going to make my pen a little not as fat. Boop. Differentiable. Then they're saying, is there a point from 0 to 4 such that the derivative will equal my average slope? You guys, from 0 to 4, what is my average slope going to be? 0. It looks like it's going to be 0, right? Does the mean value theorem guarantee that there will be another point that has a slope of 0? The mean value theorem doesn't apply because it's not differentiable. So we're going to say no. Value theorem, and you can just write MVT. AP is good with that. Mean value theorem does not apply because, what do they say? What do they call this graph? F of x is not differentiable. Has to be differentiable for us to guarantee that there's some other point that has the same slope. Okay, here we go. They said it's continuous. This is from, I can't remember what year. Do you agree that this graph looks continuous? Woo! That's all I said. There's my continuous graph. We got 2 quarter circles. Here's a quarter circle. Here's a quarter circle. And 1 line segment. Okay. Find the average rate of change from -4 to 3. That's 1 point right there. Let's go get that 1 point. I can't remember what year this is from. From -4 to 3, can we go find our average slope from right here to right here? What's it going to be, positive or negative? Negative. What's it going to be? What minus what over what minus what? And Thomas is not going to simplify it. What minus what? Beautiful over. Beautiful. Thomas is going to leave it there. The rest of us, we're going to simplify it. -2/7. And it's saying, go find that average rate. Boom, we just got a point. They said there is no point C from -4 to 3 where the slope is equal to this average rate of change. Why does this not contradict the mean value theorem? Why is there not another point that, guaranteed to have that same slope. Like my slopes don't look like they're ever parallel to it. Because there's a cusp or a corner. My function is not differentiable, and that's why it's not contradicting the mean value theorem. So we're going to say that. I know it seems redundant from what we just did before, but it is important. Because f is not differentiable, the mean value theorem, MVT, does not guarantee a point C where, and I'm just using their language right here, f prime of C equals the average rate. F prime of C equals the average rate of change. Last one. Here's my function. Mean value theorem guarantees the existence of a value C from 1 to 3 such that the derivative will equal what? So, you guys, did they say that this is continuous and differentiable? They didn't, but do we know an x cubed graph is continuous and differentiable? So they're expecting us to know, oh, because it's just an x cubed, it is going to not have any cusps or corners. I know this is a little uncomfortable. So it says the mean value theorem says that the derivative will have to equal what? My derivative is going to have to equal the average rate of change. You guys, just don't forget the mean value theorem. Maybe we write ourselves a reminder. It's just f of b. Whoops. It is just f of b minus f of a all over b minus a. And that's going to equal f prime of c. That's just saying that the average slope will equal my derivative at some c. And look what they want. They just want to know what is f prime of c going to equal. Guys, we just need this right here. We just need this. What would we use as my b and my a here? 3 and 1, right? So I'm going to do, all right, what's f of 3 minus f of 1 all over 3 minus 1? Ooh, no calculator. Gross, you guys. 3. 3 cubed is 27 times 2. 54 minus 3 squared is 9 times 4. 36 plus 1, that's gross, y'all, minus parentheses, plugging in a 1 here. 1 cubed times 2 is 2 minus 4 plus 1. Unfortunately, Thomas, we got to get an answer because it's multiple choice. We are smart people. We can do this. 54 minus 36. 18 plus 1. 19 minus 2 minus 4 is negative 2 plus 1 is negative 1. 19. Yeah. 20 over 2 is 10.